Hi, I'm Felix Winstone at Talkative. Here is a talk I gave last week in Sweden about AI and the contact center. Now, in this talk, we're going to be discussing how AI is being implemented in contact centers today and talking about some customer stories and some practical lessons learned and hopefully some useful information when it comes to considering how to deploy these systems. But first, I want to take a bit of a detour to understand some of the background around the technology itself, because it really is useful to understand, because when you're actually implementing the systems, if you know how the technology works, you're in a much better place to implement it effectively. So AI today is generally, when people are talking about AI, it's LLM, large language model. To understand an LLM, we first need to understand what a neural network is. So neural networks or artificial neural networks have been around since the 1940s. And the original thinking was, how can we make an intelligent computer? Well, the best example of intelligence that we know is the human brain. So what if we made an artificial computer that kind of works and looked a little bit like a human brain? So there's an analogy here to how an artificial neural network works and how the brain works. So in a brain, you've got input, in this case, vision, looking at a cat. That goes through your biological neurons and tells your brain, this is a cat in a conceptual manner. So a neural network takes inputs, it puts them through a number of layers, interconnected nodes, and gives you an output. And those interconnecting nodes or neurons are formed by observing patterns. So a large language model is an artificial neural network, but it's specifically trained to predict the next word or the next token in a sequence. So in this case, cat sat on the next word is meant. And the way the neural network works is it takes your inputs, in this case is a number of tokens or number of words. It could be a simple short statement like this, or in today's LLMs, it could be an entire book or an entire code base. And it will predict the next word, add that word to the existing input, and recursively go around predicting the next token, until you get an end statement, in which case you've got your complete answer. So the magic of the LLM is these neurons or these interconnecting nodes that will actually tell the LLM, the network, what that next token is. And if you look inside an LLM, it's very unlike traditional software. It's just effectively a large matrix. Think of it almost like a spreadsheet of different values. And each of these values represents a weight or a connection in the network. So the question is, how do we actually get the parameters or the set of neurons? And the parameters file, this is, as I said, this is the magic of the LLM. And the best way to think of it is as a lossy compression of the internet. So the way that these LLMs are trained, you get a large chunk of the internet or a large input text file. You're then training your neural network, your parameters file. You're continually updating the weights, the values in that parameters file. And this is a very compute-intensive process. And at the end of that process, you've got your parameters file. So in this case, for Llama 2, it's around, approximately 100 times smaller. And the training process forces the LLM to understand a lot about the underlying meaning that is contained in that original text. Everything from grammar and language through to conceptual meanings and understanding between different phrases and different concepts. So because of this parameters file, because it's not human readable, it's very hard to understand what particular individual neurons mean. It's very hard to understand exactly why it works. But all that we do know is, as an industry, is how to actually make the LLMs better. And it's very hard if you think about the question of how do you make something more intelligent? That's a very kind of fuzzy, hard to define concept. But making the LLM better at predicting the next word, the next token in the sequence, is something that is measurable and can be improved with both increased compute, training, and better algorithms. Because of the fact that it's this complex, almost organism that's grown rather than coded, is one way to think about it. One interesting aspect of it is that it's got this weird behavior when it comes to knowledge. So an example here is, who is Tom Cruise's mother? It knows that. But if you ask the inverse of that question, which to a human, if you know one, you surely know the other, the LLM, in this case, doesn't know the answer. And that's because the LLM doesn't have a database of everything that's on the internet. It's just storing that compression. So it's got kind of a fuzzy understanding of all the facts that it's being trained on. It doesn't actually know the facts and is not able to refer to them. Obviously, all of these AI tools are getting faster, smarter, and cheaper. There is still a debate as to whether we've sort of topped out on what are called the scaling laws, but the scaling laws say that if you can increase the amount of compute, the amount of parameters in the model, and the amount of data that you're training on, you can get, with the same architecture, the same algorithms, you can get correspondingly better next word prediction accuracy. So that's why you see going from GPT-2 to GPT-3 to GPT-4. The architecture was largely the same, but it was just a scaling up of all those input components that led to a better overall intelligence of the model. There are a number of other aspects in which the LLMs are getting better and better. And that's probably a subject for another talk. But I think the takeaway with this, when it comes to contact centers, is you really need to stay on top of the advances in the capabilities. We often speak with organizations that tried AI 12 months ago, 6 months ago, and there's an implicit assumption that the capabilities have not improved since then, but that is very much not the case. And I think if you're an enterprise thinking about deploying AI, you need to be dipping your toe in the water, so to speak, to get a better understanding of how these systems work, because they are very different, they're very unique. And the best way to learn is by doing, and ideally, if you're starting off with some kind of limited POC, you're at least getting to understand by using it yourself. So how is AI actually being used in contact centers? We often see there's a real, almost a branding problem with contact center chatbots. And if you speak to most people on the street or speak to your friends, you often end up concluding that these chatbots on websites are really annoying and you just want to speak to someone. Yet everyone who's used ChatGPT or Gemini or Grok or whatever, it's obviously an incredible user experience. Both of these are chatbots. So what is the disconnect here? So traditional contact center chatbots are based on what are called intents. Intents are, think of them as FAQ, specific questions with specific pre-written answers. And the way you would build these systems is you would write up all of your FAQs. You would then write up specific ways in which you expect customers to ask you about them. And when you put it together in a chatbot, you've got often a very limited feeling capability as an end user. And it often feels like it's just a glorified decision tree or menu, and there's not really much value add. And this has a number of issues. So number one, because you're quite inflexible with your responses, you really see limited business impact because it's not really able to deal with many customer questions. And if anything, you're going to annoy your users. Also, from a setup perspective, you either have to essentially employ one or two people to not just set up these chatbots, but continually monitor and improve them. And it's a big effort. Or you spend 50, 100K on a chatbot agency and they'll put something basic together for you. But then you're back to either paying them or continually, employing someone to manage them. And yeah, this is something that a lot of organizations have deployed, and it's probably led to this misconception in the eyes of the consumer about what chatbots are like on websites today. So the new paradigm is taking the brilliant LLMs and combining them with a knowledge base and a set of tools. So in contrast with your intents, where, for example, if you ask two questions in one go, or if you asked a question in French when the response was set up in English, it would fail. Whereas with an LLM, combined with your knowledge base, you can ask it any question, and providing there is an answer in your knowledge base, it will understand what you're saying, synthesize an answer, and provide it back to you. Because the LLMs are so good at understanding and interpreting user inputs, this is literally what they're post-trained on doing. The benefit of that contact centers is you don't have to design these conversation turns, design these decision trees. All you really need to focus on is making sure that your knowledge base and your actions are there in place. And the LLM takes care of all of the rough edges when it comes to conversation turns. In terms of business benefit, needless to say, this is a much more efficient way of doing things. If you only have a contact center that's open 9 to 5, you can now have a 24/7, always on, instant response from your AI. You can also collect information before handing over to human agents. Across the industry, we're probably seeing more like 40, 50, 60%, as obviously it depends on industry and use case, but that's kind of the ballpark we're looking at for containment rate, i.e. chats or conversations that are fully managed by the AI without having to hand off to a human agent and without annoying the end user. LLMs, of course, are not perfect, and you've probably come across one of these three main obstacles or objections around using AI. And sorry to pick on DPD here, but they were famously in the news here in the UK for having a chatbot that didn't quite stick to its guardrails. So the first thing is hallucinations. If we think back to our understanding of what an LLM is, it doesn't have a knowledge base. It's just providing what it thinks is the most likely answer. And oftentimes, if the answer sounds right, that's good enough in the eyes of the LLM. So the way to get around these hallucinations is to accompany your LLM with a knowledge base. And you set it up in a way such that it will only answer questions based on your knowledge base. In addition to this fundamental setup, there are also things such as in your AI chatbot setup, you can get a second LLM or AI to ensure that the answer is in the knowledge base. So you're almost getting a second opinion from an AI before sending the answer back to the customer. Additionally, as these models get better and better and better, the fundamental intelligence is going up, and that is also reducing the kind of inherent base hallucination rate. The second most common objection that we hear is, I don't want the chatbot on our website having political opinions, letting us know what its favorite sports team is, or, saying bad things about the company or talking about competitors. And again, if you pair your LLM with a knowledge base and you've got a good prompt in place, you can avoid all of that. So I think in a lot of these stories where the LLM went rogue, the system was almost certainly not set up to be paired to a knowledge base, or it was just a continual open stream with an LLM rather than having enough sanitization around having discrete prompts being sent for each message and having good guardrails in place around the responses. Data compliance, obviously this is one where I was in Sweden, which is particularly of importance with the EU AI Act. There are various different rules and regulations around the world. And fortunately, there are a growing number of excellent LLM providers. Some allow you to host a model yourself. So there is a healthy competition between the AI companies, which means that if you are very privacy focused, you can host your own LLM or have a private hosted option. Additionally, you need to ensure, particularly in the EU, that any chatbot system you're using has good governance, audit trails, and you're being able to ensure that it's not making decisions around sensitive topics. And that can, again, all be managed in your knowledge base and your prompts. So the knowledge base is the key. So in our platform, we make it very easy to set up, maintain, and improve a knowledge base. And essentially what this is doing is creating a large text file. It's then broken down into chunks if it's beyond a certain size. And there's a very common methodology called RAG, or Retrieval Augmented Generation. And what this will do is, if your knowledge base is bigger than the context window of the LLM, so if the context window is 500 kilobytes and you've got 100 megabyte knowledge base, it will basically chop it up into little chunks, as they're called. And then when you're querying the LLM, it will provide the most relevant chunks to that query. So the knowledge base, the analogy I like to use is in terms of how it helps with hallucinations and accuracy of responses. If you think back to when you're in school and you go into, say, a history exam, and one of the questions is asking you for specific dates that a battle occurred. Now, like most human brains, the way you think is you're sort of reliant on your memory, and you think the answer sounds right. I think it was May 1st, 1940. I'll just put that down. However, if you have the textbook, if it's an open book exam, you can just look at the answer from the textbook and just write it in verbatim. And that's really what the knowledge base is doing when it comes to improving LLM accuracy. It's giving the AI the exact information in context, so it's not having to use its kind of lossy compression of the internet knowledge to respond to the answer. So a typical way the prompt looks behind the scenes is based on this customer's message and these bits of the knowledge base. How would you respond? What you should also set up is a fallback mechanism such that if your answer can't be found, you let the customer know, or you transfer to a queue, or you maybe ask a follow-up question. There are there's a lot more to this prompt than what we've got here. I think the system prompt we're using at the moment is hundreds of lines long, but this is the general idea. So as we've discussed, you want to make sure that if the answer isn't found in the knowledge base, that in this case, we're going to say, sorry, can't find an answer. We're going to transfer you to an agent. Once you've got this in place, you can deploy this to messaging channels. We see web chat as the most common way these tools are being deployed today, but they can equally be deployed to SMS, WhatsApp, Facebook, and so on. And it's all using the same discrete message response paradigm. So once you've got your core knowledge base set up, deploying to all these channels is something that you should consider doing if you're active on those channels. Email, again, if we break it down to its question and it's a response, is very, very similar to chat. And the tools that you're using should hopefully allow you to respond automatically to customers over the email channel using the same knowledge base you built for chat. In practice, we found that because emails tend to be a lot longer and a lot more asynchronous in terms of how the customer is messaging you, we found that the more common paradigm in practice is actually agents getting suggested responses from the AI and sending back a really detailed response in one go. So again, there are typically in email clients things like email templates. However, these rely on agents knowing that those templates exist. However, the bigger issue is they are typically a bit more like our chatbot intents, where they're very inflexible and they often need a lot of rewriting. So having the LLM suggest an entire email response to agents saves a lot of time and allows the agent to give a more consistent answer. Voice is an increasingly exciting deployment of AI in contact centers. As with chat and email, you can use the same knowledge base to give suggestive responses. However, obviously voice is different to these text-based channels. So there are two approaches to deploying AI with voice in the contact center. The first most common approach today is using a speech-to-text layer and a text-to-speech layer to intermediate between the voice that your customer is using and the text-based LLM. So the way this would work is you use your same knowledge base and set of prompts and LLM. And when someone calls in, that voice utterance is converted into text. The text goes to the LLM, comes back, and then is converted into speech to the caller. So this is a massive increase in performance compared to your traditional IVR, where it's, press 1 for sales, press 2 for support. And there are a growing number of use cases here. The nice thing about these text-to-speech models is they sound very realistic, and you can even upload your own custom voice. So if you've got a particular dialect or accent that you want to reflect your brand, you can do that with today's tools. The other way of doing voice AI is a speech-to-speech model. So with the whole text-to-speech and back again, the drawback of that is the tone and underlying emotion and the rich information that is conveyed when speaking on a call is lost when it's converted to text. So if I say, "Oh, that's great," as far as the LLM is concerned, that is maybe not seen as a sarcastic thing, but depending on how I say it, it could be a good or a bad thing. Now, a speech-to-speech model is is similar to the text-based LLM, but rather than text in and out, it's audio in and out. But it's using the same architecture, the same fundamental approach to training and improving it. The advantage with the speech-to-speech model is it has a much better grasp of your tone. It's much lower latency. So with the text-to-speech and back again, it's probably 1 to 2 seconds for a response, which is perfectly adequate for all these use cases because you're not going to be able to fool someone that it's a human when you've got that delay. And you can still get good enough responses. You can get the information you need. Speech-to-speech model is, a lot lower latency. It feels a lot more like speaking with a real human. The current drawback as of May 2025, and this I'm sure will change soon, is the speech-to-speech model is a lot more expensive and it's a lot more limited in terms of the voices, the languages, the accents that you can use. But I've got no doubt that's where the industry is heading very, very soon. So what we've talked about so far is how the AI is helping customers on customer-facing channels. The other key, most common use case is this co-pilot or agent assist type use case, where we're taking the same knowledge-based driven AI and we're suggesting responses to agents, within a conversation, whether it be chat, email, or voice. The idea here is you are having the human make the final decision, but the AI is making things quicker and is speeding up the process of getting the right answer to the customer. There are a number of other tools which we're seeing being deployed with success. Everything from translation to automatic tagging to being able to rephrase a message that you've written to make it more suitable for the conversation. I think this is one relatively common paradigm we're seeing, where if an organization is a little hesitant around AI and just want to understand the quality of the answers, if you're first pointing your AI knowledge base at your agents, that's like a good sort of first intermediary step to give you the trust and the confidence and to see the value before pointing it and making it externally facing. Also in the contact center, it's not just agents, of course. You've got supervisors, QA analysts, admins, and AI is obviously helping all those roles as well. The most common use case today is summarization, whether this be for a single conversation or en masse. And we're really seeing a change in how QA and even traditional measurements like NPS and CSAT are done, because you can get an AI to score, rank an interaction and provide not just historical reports on that you can drill down on. So in this case, we've got, the top 10 topics, but you maybe want to ask, what are the most common reasons customers ask for a refund? Or which 3 products have the lowest customer sentiment based on transcripts? And you can do all this instantly with AI now. In addition to this historical reporting, you can get real-time alerts as well. So if a customer is being particularly irate, or if an agent is, speaking about a topic they shouldn't due to compliance reasons, you can automatically flag that. And you can do all this in a natural language driven way. So you can define what are the things you care about and then get the alerts and the reports when they happen. I think one of the most common misconceptions we see in the field is when we're introducing these AI tools is someone will say, well, does the AI learn? While it is possible to take your transcripts and fine-tune your AI based on those answers, we feel, at least today, for the majority of contact centers, that's the wrong approach. Instead, the way we think about it is you want to improve your knowledge base and the set of tools that your AI is using. And the best way to improve the knowledge base is, or one of the best ways, is by using your customer conversations to mine new knowledge additions and to keep your knowledge base in shape. So the way this manifests is if the AI keeps getting questions about something it can't answer, or even if it gets asked once, that will then surface to a supervisor or to an agent. And then if in their response to the customer for that question, or if it's showing up in your reporting, you're then adding that into the knowledge base such that next time that customer that asks a similar question will get the right answer. So it's kind of this virtuous cycle where you're using, or by using the product, you're improving the knowledge base, and that's making it more effective over time. So what are some real world examples? So one of the retailers using the Talkative platform is in the UK, but sell internationally. And they've seen for product queries a quite astounding 90% containment rate. For general inquiries, it is lower than that. But they've seen a real uptick in terms of being able to manage inquiries through the website, being able to give customers questions or being able to answer questions quickly. Because it's tied to the knowledge base, it's very good at people trying to trick it, which were largely the internal team when it was first being deployed. And an interesting observation that we found is that sometimes people would ask a question and would get a response, and they would still then actually want to speak to a human because they really just wanted to make sure. And in all those cases, the original answer was correct. It was just perhaps more an indictment of the classical way that, or historic way that people have conceived these chatbots as being a bit unreliable. One thing that we haven't talked about at all in this talk is the use of tools. So in addition to answering questions in a knowledge base, the AI can also use deterministic tools such as lookups into CRMs or APIs. And one of the really common use cases for retailers like HealthSpan is being able to answer questions like, where is my order? The customer gives their order code. That goes into a CRM lookup. It's then giving that deterministic answer back to the customer. Camden Council is another user of the Talkative chatbot platform, and their particular use case is quite different. So they are using, or one of the main areas they're using AI is to help the housing repairs team. So this is obviously something that an AI cannot easily solve if you have damp or mold in your house. What it can do is collect all the information from you as a resident and ensure that when that inquiry gets through to the service team, they've got everything they need and they don't need to waste time going backwards and forwards. Camden is also a very multicultural part of London, and there are a lot of different languages that need to be supported. And the beauty of the LLM is that it's very, very good at all these different languages. So they have deployed this across WhatsApp, and I've seen a real benefit from doing this. And this has also been part of their wider channel shift to move from telephony to more digital self-service channels. So we're going to end with some common misconceptions. The first one we've talked about already. The second one is unfortunately a reality that most organizations are finding out at the moment, is that a lot of the information on their website and documentation is perhaps out of date. And the AI is only as good as the documentation you give it. So this is something that I think is a key challenge and opportunity, in fact, for all organizations deploying AI in the contact center. The third point is while adding knowledge into a chatbot is very, very easy. It's drag and drop, it's click to upload. If you have a CRM or a database or some system that you want the chatbot to interface with, if that system is well set up, has nice APIs, that's a relatively straightforward thing to do. However, a lot of systems are not like that. So because so many organizations will be using either antiquated or bespoke systems that are not easily accessible by externals, we've often seen this become more of a challenge than it would ideally be when considering buying these tools. MCP is something that's new and is promising to make this a lot easier. But again, as of May 2025, the reality is that there is still often some development work from either your chatbot provider or the database provider to make that connection work in the way you'd want it to. The fourth point is, I think, probably touching on, again, this, because AI has been improving so quickly and so dramatically, some people are still thinking that it's more like your traditional chatbot where it's just taking a pre-written answer and putting it in. It's much more than that, as we've discussed. It's really understanding what you're asking and is giving you an answer that is factually correct, but is not just copying and pasting from the knowledge base. While the data doesn't have to be perfectly structured, obviously there are some caveats to that. For example, one of the clients we work with has conflicting data, and they had to obviously remedy that because the AI didn't know which answer was which, but it doesn't need to be perfectly structured in FAQ format. As long as the answer is there, and if you're reading it as a human, you can roughly make sense of it, it's good enough for the AI. And that kind of getting on to the final point then, it also means that because it's understanding, even if it's written in different language or written roughly, you don't need to have a different knowledge base for each language. So if you're a multinational, if you're operating in a lot of different markets, you just need to get your knowledge base right once. And then there's a little bit of work, but normally it's just prompting and your customer facing text that needs to be adapted for those countries. So thank you for watching. Talkative is, as you might have guessed by now, an AI chatbot platform that really focuses on making it easy to manage and build knowledge bases and improve them over time, and then deploy that AI knowledge across chat, messaging, email, and voice. And we've learned a lot over the last number of years with deploying these LLM-based systems. We're continually trying to stay ahead in terms of new technology improvements that are coming out, but also understanding how to actually get the best out of these systems in practice. Thanks for watching.